Today we are going to look at homogeneous differential equations. First thing is, how do we identify homogeneous differential equations? A given differential equation, when rearranged for dy by dx, that's when dy by dx is made as the subject, will be like dy by dx is equal to f of y by x. It will be a function of y by x. Wherever the variable appears, it will appear as y by x. As an example, x minus y into dy by dx is equal to x plus 2y. I'm going to make dy by dx as the subject. So dividing both sides by x minus y, I get dy by dx is equal to x plus 2y divided by x minus y. And this is not appearing as a function of y by x. So to make it as a function of y by x, I look at the highest degree x term involved in this, which is x. So I divide each term by x, and then what I get is dy by dx is equal to, I divide the first term x by x, which gives me 1, 2 times y divided by x, then x divided by x is 1, and y by x. So this is what I get, and that is appearing as a function of y by x. So this is f of y by x. So if dy by dx is the same as f of y by x, then we call it as a homogeneous differential equation. What's the method then? The method is to substitute for y by x. Because it's a function of y by x, wherever y by x comes, I call that as v. Or rather, I say y is equal to vx. So that's my substitution. We're going to look at a question now. Find the general solution of the differential equation x square plus y square is equal to x square plus xy into dy by dx. The first thing is, I'm going to make dy by dx as my subject of the equation. And for that, I divide both sides by x square plus 2y. So I get dy by dx is equal to x square plus y square divided by x square plus xy. So I have made dy by dx as the subject. Now how do I make this into f of y by x? And to make this into f of y by x, I divide each term by the highest power x term, which is x square. So what do I get? Dividing each term by, that's the numerator and denominator, by x square, I get dy by dx is equal to, I divide x square by x square giving me 1. I divide y square by x square, which is y by x the whole square. X square by x square is 1. xy divided by x square gives me y by x because 1x cancels. So this is what I get, and which is actually f of y by x, and therefore it is a homogeneous differential equation. Now, when this question is given to me, how do we identify it as homogeneous? First thing is, when I look at the question, I always check if it is variable separable. If these two variables are x square and x and y are being added up, x square plus y square, this is not going to be variable separable. You try to separate the variables, you won't be able to do it. And that's the time we check whether this can be homogeneous. A rough checking when a question is given to you could be, check the degree of each term. X square degree is 2, y square degree is 2, x square degree is 2, x into y degree is considered as 1 plus 1, which is 2. So all the 4 terms have the same degree, and therefore it is homogeneous. But this is the actual way of proving that it is homogeneous differential equation. Now once you identify that dy by dx is a function of y by x, I'm going to call that y by x as v. That's my substitution. So I say let y by x be equal to v, or y is equal to v times x. Now I'm going to differentiate this relation with respect to x. When I differentiate this relation with respect to x, y will become dy by dx. But on the right hand side, I have product rule to be applied. So differentiating with respect to x, dy by dx is equal to product rule. Applying product rule, uv rule, u into v dash plus v into u dash. So v into the first function, v into derivative of the second, derivative of x is 1, plus second function x into derivative of the first is v. So that's the product rule. Once again, v into first function into derivative of the second is 1, plus second function x into derivative of the first is, it's the derivative of v, which is dv by dx, because we are differentiating it with respect to x. So I make these substitutions into my equation number 1, which was dy by dx is equal to 1 plus y by x the whole square divided by 1 plus y by x. I'm going to make this substitution. I found what is dy by dx. My dy by dx is v plus x dv by dx, and the right side becomes 1 plus y by x has been substituted as v, so 1 plus v square divided by 1 plus v. I'm going to rearrange this. So x dy by dv by dx is equal to, I subtract v from both sides. There is a v here. I shift it to the other side. It becomes minus v. And then I take LCM. This 1 plus v goes up there. So it's going to be x dv by dx is equal to, when I take LCM, this 1 plus v goes up there. So I get minus v into 1 plus v divided by 1 plus v. And I'm going to open the brackets now. So this is what I get, 1 plus v square. Then minus v into 1 is minus v into plus v is minus v square divided by 1 plus v. Then this plus v square and minus v square will get cancelled. So what is left now is x dv by dx is equal to 1 minus v by 1 plus v. I'm going to cross multiply both the ways. And so I get this 1 plus v coming to the left side. So that makes it 1 plus v into x dv. This by dx goes to the right side, which makes it 1 minus v into dx. And then we try to completely separate the variables. And when you separate the variables, now it is variable separable at this stage, because you don't have the two variables x and v being added up anywhere. It's 1 plus v times x, and this is just 1 minus v. So I separate the variables. So what I get is I shift this 1 minus v to the left side. So it becomes 1 plus v by 1 minus v with dv. And I take this x to the other side, which makes it 1 by x dx. Once the variables are separated completely, I can integrate both sides. So I say integrating both sides with, so this is going to be integral of 1 plus v by 1 minus v dv is equal to integral of 1 by x dx.